This is Geometry 3.6b, Angle Pair Relationships, day number 2. What we're looking at are corresponding alternate interior, alternate exterior, and consecutive interior angles. So you're going to look at the placement of these letters, and are they representing which type of angle? You put those letters into the boxes. So these letters here, they're in corresponding position because they're both up and to the left of each vertex. That's different than, say, this type, which is up and left, and this one's down and over. So these are not in corresponding positions, but these would be an example of corresponding. So you would write those letters in the corresponding. So go ahead and do the rest of the letters, and then you unscramble the letters for each box, and each box writes a new word. Okay, pause the video, give that a try, and then come on back and we'll talk about it. So we notice CN and letter A. If you're not sure about the names of these angles, you can always flip the page to what we did yesterday, and we talked about the angle types here, and actually on the previous pages. Those would be called alternate exterior. They're on opposite sides of the transversal, both on the outside of the two lines. There's your two lines. These are the interior angles. Those are alternate exterior angles. So we're going to write CN and the letter A. These are both from the vertex, both up and to the left, up and to the left. They're in corresponding positions. They're in the same positions. So that's corresponding angles. So we got N and H. These, if you look, they're not in corresponding positions. Up and to the right. This is down and to the right. They're not both upright, upright. That would be corresponding, not down here. So these make a C shape. We call those consecutive interior angles. Here, in between the two lines, are your interior angles. They're on opposite sides of the transversal, so those are called alternate interior. Remember, they have to have different vertices, so you could never call the linear pair alternate interior. They have to have different vertices, non-adjacent. GI, up and to the right, up and to the right. They're in corresponding position. So GI, down and to the right from each vertex. They're in corresponding positions. NTO. All right, so those are your boxes. We have all the letters placed in them. Can you unscramble them? Is there an easy one out of the 4 boxes? Each box makes one word. One word. Is there a particular box that's the easiest to work with? I see here the only abbreviation, or the only unscrambled, not abbreviation, but the only unscrambled I can come up here is CAN. Good. Very good. Tonight. Okay, if we say tonight, would that require 2 T's? For tonight? So nope, don't think we can call it tonight. Good try. Gold. Gold can. Nothing. No thing. Okay? Nothing gold can. What's our last word? Nothing gold can stay. And that should be a Robert Frost poem. You can look into that more if you're interested in that. Now we're looking over here at this figure. We know that the measure of angle 3 is 125. If measure of angle 3, that would be this one that's labeled 125, we need to find the other 7 angle values. You're going to use the fact that the lines are parallel. We know that because of these arrows. Those arrows indicate the lines are parallel to them. So if the lines are parallel, then all these different types of angles have special relationships. If we just go right in order, we're not even going to use the parallel lines. We're not even going down to the other line at all. We're right up here with angle 1. These are vertical angles. And we know vertical angles are always congruent. It has nothing to do with the parallel lines. Angle 2. This one was 125. Angle 2. There's a couple different ways we could calculate that one. But it would typically be done with a linear pair with one of the numbers we already know. A linear pair that's going to give us at 55. Angle 4. Angle 4, you could say that it is vertical with 2. You could say that it's a linear pair with 125. Either way. Probably vertical is the easiest one because it's the same number. But even the linear pair would have given you 55 degrees. Angle 5. Now, angle 5, there's a few ways you can work with angle 5. You could talk about the corresponding angles, both up and to the left of the vertex, up and to the left of the vertex. Those are called corresponding. And if the lines are parallel, then corresponding angles are congruent. So angle 5 has to be 125. Angle 6, you could say is a linear pair with 5. You could say it's alternate interior with 4. You could say it's corresponding with 2. There's lots of different ways you could do it. But it's 55. 55 degrees. Angle 7. Angle 7 is vertical with 5. Corresponding with 125. Alternate exterior angles with angle 1. Lots of different ways you could consider that to be 125. Angle 8. Vertical with 6. Corresponding with 4. Alternate exterior with 2. Lots of different ways to do that. If the lines are parallel, then those types of angles, many of them are congruent. Consecutive interior angles, notice, those are supplementary. Now we come down, we work with some variables. This is the same idea, but what do you see? What's something you notice when you look at this figure? The math itself is easy. If I told you what to do, you could easily do it. But deciding what to do is a challenge. What do you see? That's going to help you determine what you can do. I see my two arrows. Those are going to be parallel. So if the lines are parallel, I'm going to look for one of these types of angles. Look at this card. I'm going to use this card a lot in the future. If two lines are parallel, whenever you see lines are parallel, you think about looking for these angles. Every time. Parallel lines, you look for these angles. So I have parallel lines. I see a pair of zigzag. I see a pair of angles that create a zigzag. So that means if parallel lines then alternate interior angles are congruent. That would be the theorem we would use. In your homework it says these two angles, I think they just have numbers there, like angle 1 and angle 5. These two angles, what theorem justifies their congruent? And it would be a statement like this. It's got to be if then, that's what a theorem is for us. If the lines are parallel, then the specific type of angles, many of them are congruent. One of them is supplementary. Consecutive interior is supplementary. But these are alternate interior. So we have 9x equals 72. So you're going to equal these to each other because the angles are congruent. Then we divide, and x equals 8. We come over here to the next example. What do we see? We know that this angle here and this angle here, they're considered corresponding angles. So those angles would be congruent to each other if the lines are parallel, and we know they are. But we're not working with blue over there. We know that this angle and this angle they're congruent because they're considered alternate exterior angles. But again, they're not both pink, they're not both blue, so you cannot set them equal to each other. What are we going to do with the pink and the blue? What do you notice about the relationship between a blue angle and a pink angle? If the blue are congruent and the pink are congruent, what happens to the pink and the blue in either situation? Those are going to be supplementary angles. So this is a pattern of supplementary angles. One interior, one exterior on opposite sides of the transversal, non-adjacent. Those are always going to be supplementary. We don't have a special name for that. No special name. But they are supplementary for the reasons we've talked about here. X plus 5 belongs up here because they're corresponding, and together they make a linear pair. So 3x minus 7 and x plus 5 equals 180 degrees. Together the x's become 4x. Together the constants become negative 2. You add your 2 to the other side. We divide by 4. So 4 goes into 18 4 times. That's a total of 16 with 2 left over. 4 goes into 22 5 times. But there's still 2 left over. So that's 2/4, otherwise known as 1/2. So it's 45.5. If you use the calculator on that, then you'd get 45.5. That's fine. But I'm trying to show you, you can do this calculation without a calculator. Here's probably some of the toughest questions that we've got. These are little puzzles. You got to figure out the puzzle. You got to look at the relationship of the angles that you have. Notice that 3y plus 2 is this little space inside there. So we're trying to figure out what the value of x is and what the value of y is. So you're looking for things. What do we know when we look at this picture? What do you see when you study the picture? I see a pair of arrows. Those arrows tell me that those lines are parallel to each other. And when I see parallel lines, I think about these these 4 types of angles. Which pair do I see here? I see a zigzag. So if lines parallel, then alternate interior angles are congruent. So that means my 4x is going to equal my 52. The 4x is part of my zigzag, and so is the 52. The 3y plus 2 is not part of that angle. It's not bounded by the blue. It's only touched on one side, but not on another side of the blue. This angle 4x is completely the blue. So we divide by 4, we divide by 4. 4 goes into 5 one time with 1 left over. 4 goes into 12 3 times. We get 13 for x. So the actual math is somewhat easy. Once you know that you're supposed to equal it, then it goes real well. What do we see here to help us figure out why? What do you notice about that? I see we have a 90-degree angle here. These angles make the letter C. And we know from before, let's see if I can find it real quick for us. We know from before that the C shape are considered consecutive interior. They are supplementary to each other. So I know that this 90 and this combined angle of 4x and 3y plus 2 completely add together to be 180 degrees. If I subtract the 90 and I use my x value in for my x, my 13 in for my x, I get 52. I'm going to subtract the 52 and the 2 additional, so that's a total of 54. I'm going to get 3y equals, that's 54 total, so that's going to be 36. So I get y to equal 12. I subtracted both the 52 and the negative 2, so that's a total of 54 I'm subtracting from the 90. And the 3y is left by itself. All right, let's look over here at the other puzzle one. What do you see? When you start to look at this, where do your eyes go? What do you recognize? You got to study the picture. I notice I have a pair of arrows. When you have a pair of arrows, you start looking for the specific named angles. Whenever you have parallel sides, you look for the angles. Do I have a C shape? Maybe. Do I have a zigzag? Definitely. In this corner of the zigzag, touching on both sides of the blue, is X. On this side of the zigzag, touching on both sides of the blue, is the 45. So I know that X is going to equal 45 degrees. If two lines are parallel, then alternate interior angles are congruent. We use that one a lot. The 85 and the Y. Get some more pink in there for us. Those are making an F shape. So we know that those are called corresponding angles. They're both up and to the right of its vertex. Up and to the right of its vertex. So Y is going to be equal to 85 degrees. So sometimes puzzles are a little bit easier to work with. All depending. The last thing we're going to look at is the converse. Yesterday we learned that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So today we're going to cut that down a little bit. If corresponding angles are congruent, now we're saying it in the other order. If the angles are congruent, then what do I expect about the lines? What are the lines going to be? If the angles are congruent, if we can prove that these are the same, what would we expect the lines have to be? They would have to be parallel to each other. If alternate interior angles are congruent, let's see, these are corresponding. Did I say that right? These are corresponding angles. These are alternate interior angles. they're congruent, the lines are going to be parallel. So this is proving lines parallel. How would you prove lines parallel? You have to look for one of these types of angles. You have to show alternate interior angles are congruent, or alternate exterior angles are congruent, or consecutive interior angles are supplementary, or corresponding angles are congruent. You have to show that. So this is a theorem. To show the lines are parallel, I would first have to be able to show the alternate, you're missing a word here, alternate exterior angles are congruent. And the last one, 3 and 5. Notice that one is a bit smaller angle and the other one's a little bit larger angle. Together, they're going to be supplementary. So if consecutive interior angles are supplementary, if they are in fact adding up to 180, then that's going to force the lines to be parallel. So you now can prove lines are parallel by showing one of those types of relationships.